Hello friends, welcome back. In this video, we are going to be learning HSPR. HSPR stands for Hot Standby Routing Protocol. It is a first hop redundancy protocol, which means this protocol is used to protect the default gateway of our network. So the basic functionality of first hop redundancy protocol is to protect the default gateway of our network, because default gateway is the essential device for a network. So in order to reach other networks, we need to communicate with our default gateway. Otherwise, we cannot communicate to the internet. Okay. So let me show you how it is happening. Okay. So here we have two default gateway instead of a single default gateway. Okay. So router 3 and router 4, they will be our default gateways. Okay. So now we have two routers. So two routers are our default gateways. So and this IP address is for router 3 and this IP address is for router 4, and this IP address will be our HSPR virtual IP. So this IP address is going to be our default gateway's IP address. But actually, this is the IP address of R4 and this is the IP address of R2, and they will have HSPR virtual IP address. So one of the default gateways will be active and the other will be standby. So the active router will function and the standby router will be ready to, if the active router fails, the standby router will take the position and do the job. Okay. So now I have configured the basic configuration on the routers. Let me show you. Okay. Here you can see the DHCP configuration. This is the network and default router on that one. So on the both routers have configured DHCP. Okay, so on the both routers, same DHCP pool. I have created the same DHCP pool on the same on the two routers. Okay. Now let me show you the interface. Show IP interface brief. Here you can see the interface fast Ethernet 0/1 and the IP address is 1.2, and on the R4 show IP interface brief, and you can see the interface fast Ethernet 0/0, the IP address 1.3. So I have configured the basic configuration and they will be able to ping each other. Let me show you. Ping 1.192.168.1.2. They are pinging. Okay, so I can ping the other router. So now I'm going to configure HSPR. Okay, so let's configure HSPR. So I'm going to configure HSPR on interface fast Ethernet 0/0. So this interface, okay, one, two. So this interface fast Ethernet 0/0, and on router 3 as well, fast Ethernet 0/0, I'm going to configure HSPR because fast Ethernet 0/0 is our default gateway. Okay, so let's start. So first get into the interface, fast Ethernet 0/0, then standby. Okay, standby. Then group number. Okay, so let me show you group number. We have to give the group number here. So I'm going to give group 0. The range is 0 to 255. So by default, HSPR uses version 1. So version 1, the difference between version 1 and version 2 is in version 1 we can create 255 groups, because you can see here 0 to 255. In version 2 we can create up to 4095 HSPR groups, because per VLAN. So if we have VLAN configured in our LAN, we can use version 2 because we can have up to 4095 groups. So each group, sorry, so per VLAN. So per VLAN, one group per VLAN. Okay, so like that. Next IP. Next, our virtual IP address, which is 192.168.1.1. This is our virtual IP address, and I have given the virtual IP address. So next, priority. So I'm not going to give any priority on R4. Okay, so it will take the default priority, which is 100. So next go to R3, config T, then interface fast ethernet 0/0, then standby. So group number should be same. So 0, then IP, then the virtual IP address. Here I'm going to give the priority. Okay, priority. Okay, priority. Sorry, not the priority group. Standby priority. So I'm going to give priority 50, 150 here. Okay, let's see who is going to be the active and who is going to be the standby. Before doing that, I'm going to capture traffic on both the interfaces. Okay, traffic. So now I'm capturing traffic on both the interfaces. So let's see the traffic flow on Wireshark. Okay, let's see the traffic flow on Wireshark. So let's see what is happening. Here you can see R3 is the standby router and R4 is the active router. So let me tell you the reason. So here the IP address of R4 is 192.168.1.3 and the IP address of R3 is 192.168.1.2. So 1.2 for R3 and 1.3 for R4. So which is the higher one? 1.3. So R4 becomes the active router. So here based on the highest IP address. So based on highest IP address, HSP or elects R4 as active. Here you can see the state active. And let's go to router 3. Router 3 becomes standby because it has the second or lowest IP address. So 1.2. Okay, now I'm going to give one command, standby preempt. So let's see what happens after giving this command. Here you can see the state speaking. So now they are speaking. Now I'm going to give this command. Let's see who is going to be the active and who is going to be the standby. So this router becomes the standby router. Let me show you. This router becomes the active router after giving this command, standby preempt. So what is the reason why router 3 becomes the active router? Now let's end this. Show standby all. Okay, so show standby all. Here you can see the active router is local and the standby router is 192.168.1.3 and the priority is 150. Okay, so here you can see the priority of standby router and the active router's priority is 150. So after giving the command standby preempt, the router with the highest priority becomes the active router. So this command is used to change the election, the way of electing to active and standby router. So preempt is used to change the way of electing active and standby router based on priority. So before giving the command standby preempt, the election was based on the highest IP address. After giving the command, the election was based on the priority, highest priority. Okay, let's say now let's see. I'm going to give another command. Let's see what is going to happen. Interface fast ethernet 0/0. Now I'm going to give another command, standby. Let's see, standby track. So track. So I'm going to track an interface. So I'm going to track fast ethernet 0/1. So I'm going to track fast ethernet 0/1. Let me show you fast ethernet 0/1. I'm going to track this interface. Okay, so fast ethernet 0/1. Okay, so if something happens to this interface, if something is wrong with fast ethernet 0/1, I'm going to say decrement the priority value. So decrement 51. Let's see who is going to be now the state they are speaking. So both the routers are speaking now. They are negotiating who is going to be the active and standby. Now router 3 becomes standby. What is the reason? Let me show you the reason. Okay. Okay. Here you can see the priority of this router is 99, but configured 151. And here you can see track interface fast ethernet 0 slash 1 state down. So fast ethernet 0 slash 1 is down. So decrement 51. Okay, so fast ethernet 0 slash 1 is down. So the value, the priority is decremented by 51. So 99. So 99. Okay, so and also we have already given a command preemption is enabled. Okay, so preemption is enabled, which means the router with the highest priority will become the active router. Here you can see the active router's priority is 100 and this router's priority is 99. So the priority, based on priority, router 4 becomes active and router 3 becomes standby. Let me show you again. Okay, now 51. Instead of 51, I'm going to decrease 30. Okay, let's see who is going to be the active. Now R3 becomes active. Let me show you why. Here you can see the priority is 120, configured 150, track interface fast ethernet 0 slash 1, state is down, so decrement 30. So even though 30 is decremented, we still have 120, which is higher than 100. Okay, so 120, which is higher than 100. So router 3 becomes active. He will be the active, even though it lost 30 points. Okay, so this is how they elect active and standby routers. Okay, let's go to the PCs. Okay, so they are the hosts. So I'm going to enable IP DHCP. So now the DORA process is running. Okay, now PC2 is assigned an IP address 1.4. Okay, so let's go to the router. Here you can see server pinged. Okay, so router 3 is active and it is forwarding now. Okay, what I'm going to do here is infect interface. So decrement 51. Decrement 51. So the state can speak. Now R3 becomes standby router. R4 becomes the active router. Now on PC3, I'm going to enable IP DHCP. Let's see the DORA process is happening. Here, discover offer, request and acknowledgement. Now it is assigned an IP address on that 5. Let's go to R4. So now R4 is active. So and R3 is standby. So who provides the IP address? Let's go to the interfaces. Okay, so I'm going to filter DHCP. Here you can see 1.2, 1.4. So 1.4 is assigned by router 3. This is the IP address of router 3. 1.4 is assigned by router 3 and 1.5 also assigned by router 3. Let's go to the other interface. Filter DHCP. Here we can see both the interfaces are assigning IP address. So 1.3 also replying to DHCP. So both the routers are replying DHCP request. Okay, so both DHCP servers are replying. Okay, so 1.3 source destination. Okay, so both the routers are responding to request. Okay, DHCP request. Okay. Okay, let's go to R3 again. So now let's do 20. So now R3 will become active. Let's go to PC1. Okay, connect. So PC1 is not working. Okay, let's go to PC3 and PC2. Okay, I'm going to ping 92.168.1.1. If I can ping on that one, my default gateway. Okay, so let's go here and router 3 and debug IP ICMP. I'm going to enable debug on both routers. Debug IP ICMP. So ICMP debug is enabled on both routers. Okay, I'm going to now I'm pinging 1.1.1.1. Let's see. Now R3 is replying. So now R3 is replying. Okay. So R3 is replying to my pin request, ICMP request. R4 is not replying. Okay. Because R3 is the active now. Okay. Now I'm going to give not this command 51. So now R3 will become standby. Speaking. Now they are speaking. Okay. Now R3 will become standby. Okay. R3 becomes standby and R4 becomes active. Again, I'm going to ping on that one. Let's see who is replying. Now, the reply is from R4 because he is the active router and he is replying. Okay. So even if one router fails, the other router will function. Okay. So even if R3 fails, R4 will become active and forward the traffic. If R4 fails, R3 will become active and forward the traffic. Okay. So this is the functionality of HSPR. Let's see some other commands. So here authentication is available. So we can give password and delay. So we can define the delay time. How long a standby router can become active router if the active router sometimes reloads or restarts. So that particular time only the standby router can become active. So we can define the time here, delay, then IP, then MAC address. We can manually update the virtual MAC address, a name, redundancy name string. So we can give a name here and preempt. I've already told you the benefit of using preempt command, and priority is used to assign priority value. Then timer is redirect. So it is used to redirect packets. Okay. Then timers. Okay. Let's see the timers. So here we can change the hello interval. By default, OS HSPR hello interval is 3 seconds and whole time is 10 seconds. But we can reduce the time as low as 1 second. So and also we can give milliseconds. Okay, milliseconds as low as 15 milliseconds. So I can give I can reduce the hello time as low as 15 milliseconds. So just I'm going to give 500 milliseconds. Okay. So incomplete command. So whole time. Now we have to define the whole time. So now that also I'm going to give in milliseconds. Milliseconds. The range is 1500 as low as 1500. So 1500. Okay. The same command on router 4 because they should have the same hello time and hold time. Okay. So they should match. So standby timers millisecond. So hello, which is 500 milliseconds, and hold time, which is 1500 milliseconds. So let's see what will happen. So now I'm going to. So now the router 3 is the active. I think let me show. Let me check who is the active. Standby router is local. So active router is router 4. So now I'm going to chat the interface. Okay. Now suddenly the router 3 becomes active. Okay, this is really fast. Okay, this is really fast. So we can change the hello time and hold time to make a fast convergence. Okay, so for a faster convergence, we can change the hello time and hold time. If you use default time value, so we have to wait 10 seconds for the standby router to become an active router. Okay, so that's all from HSPR. I think this is enough for HSPR. Um, let me show you the traffic or traffic. So here you can see gratuitous ARP. So HSPR uses gratuitous ARP, which means gratuitous ARP means so there will be no ARP requests in the network. So only ARP reply. So now the once the standby router becomes active, it will send a gratuitous ARP. Here you can see the sender IP and target IP address. So sender IP and target IP same, and target MAC, which is STP uplink fast. So this MAC address is 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 not the MAC address of, it is the MAC address of whose MAC address it is. This MAC address, the sender's MAC address is HSPR virtual MAC address, and the target MAC address, which is 01 colon 00 colon 0C colon CD colon CD colon CD. I think it is the multicast MAC address. It is the multicast MAC address. So we need not worry about anything. So here I am announcing my MAC address to everyone. So this is my MAC address. So the switch will receive this ARP request, then it will make a change in the MAC address table. Instead of forwarding the packet to the previous, which means former active router, now it will forward the traffic to the new active router. Okay, so this is how the gratuitous ARP functions. Let's see if any other ARP request. Here we have some ARP request here who has 1.1.1.1. These are normal ARP requests from hosts. So these ARP requests are initiated by the host PCs, and the gratuitous ARP packets are generated by the HSPR routers. Okay, so this is how HSPR functions. I think this is enough now. And thanks for watching the video, and see you. Bye bye.